This is a solution for a normal distribution in T-test mock exam. So problem number 1, the GPAs in 11th grade at the AC have a mean of 2.5 and a standard deviation of 0.4. Draw a sketch of a normal distribution with these characteristics. Okay, you've done this 1,000 times. At least that many, right? So the mean is 2.5, that goes in the middle. And then the standard deviation is 0.4. You add it to the right and you subtract it from the left. So you're going to have 2.9 to the right. You're going to have 2.1 to the left, 3.3 to the right, 1.7 to the left, like that, okay? Remember that this is about 34%, this is about 13.5%, this is about 2%, and here this would be about 0.5%, right? If we want to give an award to the top 5 students of the 42 total students, what would be the minimum GPA G to receive the award? Give G to 3 significant figures. Okay. This is a problem that is either inverse normal, normal CDF. Remember that normal CDF, you start with the GPA and you change that to number of people, right? Because the x-axis is GPA. We don't usually write what the x-axis is, but I think that it helps when you get a complicated problem. So the area is the people, right? If we want to give an award to the top 5 students of 42 total students, so 42 total students, that would be like this whole area here. The top 5 students would be some people over here, the area over here, right? So in that case, this 5 has nothing to do with the x-axis scale, right? It actually has to do with the area. But you might say, oh, but the area is not divided into people, it's divided into percent. Exactly. So you need to figure out what is the percentage of 5 in 42, and that would be the percent that you want to shade as far as your top 5 goes. Why are you doing that? Because you want to figure out where exactly is G, okay? So you're going to have some value of GPA called G, which is the minimum GPA to receive the award. This is the minimum GPA to receive the award, and everybody to the right of G does receive the award. And they said that that is equal to 5 people. And what percent is 5 people? It would be 5 divided by 42. That would be the percentage. So let's take the calculator and figure that out. What is 5 divided by 42? That gives us the percentage. It turns out to be 11.9%. I'm just going to write the decimal. So it's 0.119 people. So it says, by the way, here the hint, it says, first, what is the percentage of 5 students out of 42? It's 11.9%. Shade the percentage in the diagram, part A. Okay, and so that is a hint to figure out what G is. Now that we figured out that this blue area here is actually 0.119, we know how to figure that out, right? Now, I have an old calculator here. So with the old calculator, what I need to do is I need to figure out the left area, this green area here, and that I put into the old calculator. If you have a new calculator, you can use the blue area, 0.119, and put that directly in the calculator. Now, what is the green area relative to the blue area? It's exactly the opposite of the 100% that the blue area is in. So 0.119 is the blue area. The green area would be, if I find the difference between 100% and 0.119, I would do 1 minus 0.119, or I could like grab this and get an even more accurate answer. The answer is 0.881. Okay, so the green part is going to be 0.881. And with the old calculator, I can use the green area to find out what is G. Okay, what is the right boundary of this area? So I do second distribution, inverse normal, because I'm changing from the area to the x-axis scale. So I'm going to put 0.881. And the mean is 2.5. And the standard deviation is 0.4. and I go to paste. And the answer is 2.97. So G is equal to 2.97. It asks for 3 significant figures, and that is 3 significant figures. Okay? And if I was to do it with the new calculator, I could do it with 0.119 as long as I specified that that is a right area, right? So I can put here 2.97. For an annual report, EAC needs to calculate the first and third quartiles for the 11th grade GPAs. Find their values to 3 significant figures. Okay, this is one of the new curriculum problems, which likes to mix quartiles with normal distribution. So if you look at these pictures we drew, this is 0.119 and this is 0.881. What they're looking for is they want to know where is 0.25, 0.25, 0.25. So 0.25 is obviously going to be bigger than the blue area, so it goes a little bit further over there. And then the next 0.25 would be like there, and the next 0.25 would be, a little bit less than that, right? Because this middle part is 34%, right? So, okay. So actually, the quartiles are going to be located like here and here, right? Slightly inside the first standard deviation line. So this is going to be your Q1, and this is going to be your Q3. Okay. So let's try to figure that out. So basically, what we're going to do is we're going to say, okay, we got 2.5 in the middle, and we got standard deviation of 0.4. And we're going to figure out Q1 and Q3. We're going to divide this up into areas of 25, 25, 25, 25. So if I wanted to figure out Q1 and Q3, I would use this area to figure out Q1. This area is how much to Q1? It's going to be 25%, right? 0.25, because Q1 is first quartile. There's 25% to the left, 75% to the right. If I want to figure out Q3, what I'm going to do is I'm going to figure out this green area, which of course is 75% because there's 75% to the left of Q3 and there's 25% to the right. And I'm going to use inverse normal because I'm changing areas into x-axis values, right? So let's do that. We're going to turn on the calculator, and we're going to do second distribution inverse norm. And I'm going to put in 2.5, or I'm going to put 0.25 for the area, the yellow area, and I leave mu and sigma the same, and this is going to give me a value for Q1, which is going to be 2.23. That's the Q1 GPA. And if I want to figure out the Q3 GPA, I put in 0.75. So you have a couple of options on how to do this with the new type of calculator. But with the old type of calculator, this is what you would do. Actually, whenever you get one of these quartile problems with the old type of calculator, all you're going to do is you're going to do inverse normal with 0.25, inverse normal with 0.75, and then you can figure it out later. Which one's Q1 and Q3? It's going to be pretty obvious because one of them is going to be bigger than the other, right? Okay, so 2.23 and 2.77 are the Q1s and the Q3. Okay, now you notice that I didn't have any norm CDF problems in here. I was kind of limited in space because we're going to do an exam with normal distribution and with t-test, and so I didn't have a lot of space to put in a norm CDF problems. The norm CDF problems, just to review it here, are pretty straightforward, right? Let's say that we were going to do the opposite here. Let's verify that the area between 2.23 and 2.77 is the middle 50% by doing norm CDF, okay? So we'll go second distribution, norm CDF, which is number 2, and we're going to put Q1, which is 2.23, and Q3, which is 2.77. So 2.23, and then we're going to put 2.77, and the mu is 2.5, and the sigma is 0.4, and this should give us close to 50% because that should be the middle 50%. Yeah, it's pretty close, 0.500. Okay, so the middle 50% of the students are between 2.23 and 2.77. Okay, so the answer to this one was 2.23 for Q1, and then Q2 was 2.77. Okay, all right, let's go to the second page. So now we're going to talk a little bit about t-test. Okay, oops, I forgot to leave the reflection space on this. Need to fix that. Okay, so the 2026 Math HL cohort believes that they are academically superior to the 2025 cohort. Mr. Tsubaki wants to compare the first semester math grades from the two cohorts to see if they are. Here are their grades. So I have 1, 2, 3, 4, 5, 6 math grades from 2025, and I have 1, 2, 3, 4, 5, 6, 7, 8 grades from the 2026 cohort. Remember, with t-test, it doesn't matter if the number of samples in the two groups are different. Okay, it doesn't affect the test. Okay, so we're going to do 10% significance level. Significance level of significance. Oops. A t-test was used to compare the means of the two groups. The data is assumed to be normally distributed, and the standard deviations are equal between the two groups. Okay, which means that we can do pooled, right? All right, state the null hypothesis in a sentence. Okay, the null hypothesis is that the 2025 cohort mean exam is same as 2026 cohort mean exam. Okay, and the alternative hypothesis, what we're looking here is either that the 2025 cohort mean is not the same as the 2026 cohort mean, but actually we're specifically looking for something else. We're looking to see that the 2026 cohort mean exam is higher than the 2025. So let's say that the 2025 is mean 1 and 2026 is mean 2. So we're looking to see if mean 2 is greater than mean 1, or mean 1, let's say that mean 1 is less than mean 2, because usually on the calculator mean 1 comes first. Okay, so basically, how do we say that in words? We're going to say that the 2025 cohort mean exam is less than the 2026 cohort mean exam. Okay, so let's do the calculate. We're gonna put in the data, and then we're gonna do the calculation. So we're gonna do stat edit, and then we're gonna have list 1 and list 2. We're gonna put mean 1 data here and mean 2 data here. So I'm gonna put 76, 83, blah blah blah. Here I'm gonna put 74, 80, blah blah blah. So I'm gonna do that, and then I'm gonna be back in a second. So I'm gonna pause. Okay, so I put the data in here. I got 76, 83, 74, 87, 91, 93. 74, 80, 82, 83, 84, 89, 91, 92. Okay, so I'm going to do stat, test, and then I'm going to go down to option 4, which is the 2-sample t-test. You're always going to use the 2-sample t-test for the exam. You're always going to put data because we got data for both. We don't have mean and standard deviation. We actually have data. List 1 and list 2, it's convenient if you always use that. Frequency 1, frequency 2, put mu 1 for both. And then we put in our alternative hypothesis. Our alternative hypothesis is that mu 1 is less than mu 2. So I'm going to put that. And then pooled is yes. We're always going to be put pooled yes for the exam. And then we do calculate. So our t value is, I'm just going to write it here. They didn't ask us for the t-value, but I'm going to put it here. Negative 0.101. Our p-value is 0.460. And what we're going to do with the p-value is we're going to compare it to the 10% significance level, which is 0.10. So 0.460p is greater than 0.10, right? So p equals 0.460 is greater than 0.10. So since the p-value is greater than 0.10, that means we accept the null hypothesis. So we accept the null hypothesis that 2025 cohort exam means are the same as 2026. So in the end, 2026 thought they were better than 2025, but the data doesn't show that. It shows that they're the same, virtually the same. Okay? If you look at the X1 bar and the X2 bar, it looks like there's a slight difference between the two, but the difference is not big enough to draw the conclusion that the 2026 cohort is academically superior. Okay? Is that it? Yeah, that's it.